Hello! In this lecture, we will discuss about delegation and inheritance. So the goal of this lecture is to analyze different designs of the same system, some based on inheritance and some based on delegation. And the idea is to compare those designs given some criteria or hints to analyze which one is the best one. So the exercise setup that we will use is imagine that we want to design a text editor with different algorithms to format the text. So how can we do that? So perhaps we have some text formatting for tech or text formatting that is fast, another text formatting that is slow but very precise, etc., etc. The agenda of this lecture will be the following. We will do a first design based on inheritance, another design based on conditional. Then we will define some criteria to compare those solutions. And we will then see a third solution based on delegation and we will evaluate. So let's start with the inheritance-based solution. So we will create a text editor class there. And this text editor will display the text that is stored in this instance variable. And we will have a format method there, which is abstract in this case. And we will have one subclass per text formatting algorithm. So for example, we could have slow formatting text editor there, and here we can implement it in a separate method, and we can have the fast formatter text editor and the null formatting text editor, for example. Okay, so it means that we can have different text editor, each one specialized in a specific algorithm. Another solution using only one class is the following. So here we still have one text editor with a text to display in an instance variable, but given a current selection which stores a key, for example here this is slow, given this key we will test and we will directly execute the right formatting algorithm. For example, format slow but precise coloring, and we give the text as a parameter. We could even, with this single class scenario, use metaprogramming. For example, if I want to avoid testing, because now you know that explicit texting in the clients is usually not the best solution, the idea is to have a list of formatter here, and then I will store for each, this is a dictionary, and for each key, I can store the name of the selector that I should apply to correctly format the text. And in this method, format, I will perform. So perform, this is a metaprogramming method. I will give the name of the selector that I want to invoke and the parameter that I want to pass. Okay, but this is exactly the same solution as before. So now what are the criteria to compare this kind of solution? So first, the addition. What is the cost of defining a new formatting algorithm? Is it easy? Can I package different algorithms in separate packages like that? I can load them afterwards, like plugins or something like that. And finally, is it easy to dynamically switch to another formatting algorithm? So let's review the different solutions given those criteria. For example, the inheritance-based solution, on the pro side, this is easy to add a new formatting algorithm because I just need to add a new subclass. And this is easy to package them separately. So it means I can take one of those classes, put it in a separate package, and I can load it afterwards. On the cons side, this is more difficult to dynamically switch to another formatting algorithm. Because if I instantiated my text editor at the beginning, when I open it, it means that then, when I want to change the formatting algorithm, perhaps I will need to close it and to recreate the instance. So this is not convenient at all. And another point here, this is the addition. So it was a pro, but it is also a cons because there is a combinatorial explosion that we will explain in the next slide. So here, if I have a lot of concerns in my text editor, for example, I have a single pane, multi-pane text editor, I must take care of completion, grammatical verification, compilation, etc. It means that I may end up with a hierarchy like that. So it means I will have the slow formatting text editor, like before, but then I need to have a subclass for the single pane slow formatting text editor, and then I will have the multi-pane slow formatting text editor, but I also have the spell multi-pane slow formatting text editor, and then you can see now the explosion. So I will have a lot of subclasses for each different concerns that I want to combine. And moreover, the API of the text editor, if I want to have a uniform API for my clients, so it means that it may be not clear because everything will be mixed up inside the text editor class. Now let's evaluate the conditional-based solution with a single class. On the pro side, it is really easy to dynamically switch between one formatting algorithm to another one. But on the cons side, this is more difficult to add a new formatting algorithm because I need to recompile, to edit and recompile the code that is already written in a class. And of course, since there is only one class, this is difficult to package them separately. So now you can take 1 minute to imagine a new solution using a delegation. So it means that inside your text editor, you will delegate the formatting algorithm to another object, the formatter. So here, the solution is based on the delegation. So it means that in the format method there, I will send the format message to a formatter object. And the formatter object, now I have a setter in my editor. You can see it there. And I can say, okay, the formatter will be a fast formatter. And here you have a hierarchy there, this hierarchy, that can be as complex as I want, of formatter. And all those formatters are polymorphic. They all understand the format method. So it means that now I can dynamically change the formatter on my editor, and I just need to send the format message to my editor, and my editor will forward this message to the formatter. So now I have an extensible solution by delegation. So if I evaluate this solution, so now the addition is easy. It's just a matter of adding a new subclass of the formatter. Packaging is easy because I can take some formatter class and put it in a separate package. This is easy to dynamically switch to another formatting algorithm because it's just a matter of using the setter on my text editor. And there is a uniform API between the editors and the formatter. This is the format message. On the cons side, the formatter should access the state of the text editor. So it means that the text, the position, and everything that it contains in the text editor might be useful to the formatter to correctly show the formatting text. The API of the text editor should be open to support it. So it means that it breaks a little bit the encapsulation of the text editor. And this design is a perfect, typical example of the strategy design pattern. So as a conclusion, inheritance is about incremental and static definition. It can lead to static design, and it helps defining abstraction. But delegation, on the other hand, brings a runtime flexibility and modularity. But there is nothing such as a free lunch. So it means that both of them have pros and cons, and it means that you need to evaluate what is best in your design.